in all of this information that we had already solved for. Let's see, shoot, what was this, 9 minus 6? Yeah. So -3. I think that's all the farther we got yesterday in this hour, right? We kind of finished right there? Okay, perfect. So the only thing we really talked about yesterday was just the actual graphing, like how to fill out the table. And actually, let's refresh somebody on that. Should we randomly pick somebody that's gonna start the class every day? Would be like the first person called on. That doesn't mean they have to answer first. They'll just get called on first and they can either answer it or choose somebody else. I like that. Let's choose this. Let's make a random number. We got 33 people in here. Random number 1 through 33. And Google says 27. 1, 2, 3, 4, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20. I already forgot what number I said. Did I say 23? 27, 23, 24, 25, 26, 27. Cohen, you're going to start us off every day.
Okay.
Okay. Cohen, down here, let me pick a random one of them. Next to the -2, we wrote a -5. How did we get that -5 in the first place? As a reminder for everybody from yesterday.
You plug the -2 where the x's are.
Okay?
And then we solved.
Now, what you're saying is perfect. Do you remember what we have to do on the calculator with the -2?
Put in parentheses.
Perfect. So on your calculator, you would have had to type -2 squared plus 2 times -2 in parentheses minus 5. So no matter which calculator you're using, you have to type it in the same way. So whether you're using Desmos, whether you're using handheld calculator, and maybe what I should do right now is today that's going to be definitely a part of what we're doing. Like you're going to need a calculator today, and the phone calculator doesn't really cut it for this. So if you have your own calculator, pull that out. If you don't, then get Desmos open. And if you are desperate for today, if you don't have a Chromebook, then you can download the Desmos app to your phone. That way it'll allow you to put in parentheses and squares and everything correctly. Like the iPhone and Android calculators don't really work great when you're trying to type in multiple things. Okay, well, stuff's moving up here. What I wanted to talk about today is we need to talk about what things are called on a graph. Okay, up at the top, there's a whole bunch of things listed: y-intercept, vertex, axis of symmetry, roots, zeros. So let's start with the one you guys probably remember the best. The y-intercept. Colin, who's gonna help me with this one?
Um,
Center section. Wes, all right, sounds good. Wes, do you remember what the y-intercept is?
Yes, the line that goes up and down.
Okay, so that's the y-axis.
Oh, my fault.
Yep. The y-intercept is where your graph touches the y-axis. So I think you meant it correct, yep. So we wanna, the y-intercept is always just gonna be where does your graph touch the line that goes up and down. For this picture, the y-intercept is gonna be at 0. And we are gonna write them as points, so that we don't get confused between numbers and letters and et cetera. Actually, you know what? I'm starting to think that this is gonna be a really bad example. Because half of the answers are gonna be 0. Let's go to number 2 and do the exact same things. The y-intercept on number 2 is going to be right there at -5. So we're gonna write it as 0, -5. It'll be a lot easier for us to say things individually on the second picture. So same thing, we just wanna know where it touches the line that goes up and down. Wes, somebody from over here.
I just pick a number.
Yeah,
5.
5. Ellie. If I tell you nothing about a vertex, do you ever remember hearing vertex from different things we've done? When we did the V shapes, so we did graphs that looked like V's before. The vertex was the point or the tip. Okay, on a U, where is that gonna be? Yeah, so, I'm not gonna call it the bottom, because the U could be upside down and then it would be the top. So the vertex is gonna be the same thing on a U shape, it's gonna be the point or the tip. So right here is the vertex. And then we'll give it a point, right? So this is gonna be the point -1, -6. But good. Ellie? Someone else? Oh, wait, Macy. She was just gonna call on you no matter what I gave for instruction. Do you remember how to find the x-intercepts? The y-intercept is where the graph touches this line. Do you remember what the x-intercepts are? Perfect. It's where your graph touches this line. So, the annoying thing about this, wait, how does the 0 spell? Is that E or not? No. I always hate zeros, because you can spell it with an E or not, and they're both correct. And it annoys me that they're both correct. So I figured I'd try to match what was up there. Roots and zeros are x-intercepts. For some reason, I mean, I know why they gave it a different name, but they stopped calling it an x-intercept and they start calling them roots and zeros the higher up in math you go. About where does this graph hit this line? We're just gonna say about because it's not a nice number. So if we had to give a number to it, we'll just call them halves, but. So it's in between 1 and 2, so we would call it 1.5. So one of the x-intercepts is going to be 1.5. And then the other one, what was it, what would we call that, negative 3.5? Would it be helpful if I wrote? Macy, somebody from over here. Sure. Jackie. Don't you love my counting skills? Jackie, the last thing we need to talk about, it's called the axis of symmetry. So most people think of the axis of symmetry as like a mirror image line, or a line that if you folded the piece of paper on that line, your graph would be a mirror image. So I don't know what would be the easiest way for you to try to describe it to me. Like, if I put, don't write this one down. If I said that was the axis of symmetry, and I folded the picture on that green line, would the top and the bottom be exactly the same? They would, right? So we know that that's not the axis of symmetry. What, do you think you could kind of guess where it should be, or what it should look like?
I don't have experience, like the -1 line.
Okay, good. No, I'll take that. That's very good. Straight up and down. So at x equals -1, this would be the axis of symmetry, because if we folded it on that line, the left and the right would look identical. And so we usually just give a single number, which the way you described it was perfect. You said the -1 line. We're gonna say it's x equals -1, because that would be where the line would go on top of. Now, I don't know, now that we've gone through all of these things, I'm kind of hoping you can see why I stopped at the top example immediately. Every single answer was 0. It was the y-intercept, it was the x-intercept, it was the axis of symmetry. I mean, it was like, everything was 0. Last question. Where did we go? Oh, yeah, Jackie. Jackie, last person. Alan. Are we going to have an answer for all 4 of these? Are we going to have an answer for all 4 of these every single time? Okay, can you think of one of these we might not have an answer for? So, where we maybe wouldn't is if our u was in a different spot, right? Like, the u up here is touching the line at a single spot. And because of that, like, all the answers were that single spot. What would happen if the graph was up higher? Like, if our U shape was right there, which answer would we not have if it was up there? I'm trying to think of a way to phrase the question so it's not hard to answer. Do you want some help? That's fine. Can anybody think of what I'm trying to ask? Oh, Ekram. It would have a vertex no matter where it is, because the vertex is going to be the point of the U.
I thought it had to touch the line.
Oh, got you. The vertex is always just going to, come on. The vertex is always going to be the tip of the U. Something tells me you meant the right answer but said the wrong one.
The x-intercept.
Yeah. So you're not always going to touch the x-axis. The roots and the zeros, if your u was up here, it's not gonna touch the x-axis. But you're always gonna have a tip, you're always gonna have a middle, which is this line, and it actually always has to touch the y-axis, which it seems like it shouldn't need to, like, what if your u was way the heck over there? But it actually will always touch the y-axis. The x-intercept is the only one that you don't necessarily have to have. Okay, our goal today is to do these two things. So I've got a worksheet for you that our goal is to graph the parabola, the U shape, and then to find these four answers if it has the four answers. Okay? So would you guys like me to leave this up on the board so that you kind of have that as a reference while you're working on those? There's only 3 problems to do. And then you're gonna need a calculator because you're gonna have to fill out the table for those 3 problems. So you're gonna wanna graph all 3 of them first, and then once you graph all 3 of them, then I would write down these 4 things next to each one. And there should be plenty of room. And I will gladly help you with whatever you want help with. But we're kind of starting off slow so that we have each topic we're gonna do will hopefully be easier that way. Now what I'm going to do is, I want in about 15 minutes. I'm not sure how long it's gonna take you, but I'm thinking 15 minutes is enough time to be able to graph all 3. In about 15 minutes, I wanna put up the answers for the graphs, like for the tables. It's not gonna have the answers for the intercepts, the vertex, all that kind of stuff. It'll be just the graph answers. But then that way, at least you can see if your graph is correct, because if your graph isn't correct, then the other answers for sure